I wanted to take a little bit of time to walk you through how to print out the values in a diagonal, and of course there are two diagonals in a two-dimensional array. So in the previous recording I showed you how to walk the rows, then I also showed you how to walk the columns. Now I'm going to show you how to walk the primary diagonal, which is the one that goes from the upper left to the lower right. In this case it has the numbers 1, 5, and 9. I'm also going to show you how to walk the secondary diagonal, the one that goes from the upper right to the lower left, that has the numbers 3, 5, and 7. It's not uncommon to see a question relating to two-dimensional arrays asking you to add up the values in the array. So you might be given a two-dimensional array of integers and you might be asked to add each row and print the total out, or to add each column and print the three totals out. And using the code from the other video you would be able to do that. You might also be asked to add up the primary diagonal. In this case the answer would be 15, 1 plus 5 plus 9. You might be asked to add up the secondary diagonal and print out the answer, which would also, I guess in this case, be 15. So you need to be comfortable with walking rows, walking columns, and then walking diagonals. Now notice on the primary diagonal, here's the trick with that. The elements in the primary diagonal will have the same value for the row and the column. So 0, 0, which has the 1 in it, starts the primary diagonal. The element with coordinates 1, 1 is 5. That's the second part of the primary diagonal. And notice the last part is the element with 2, 2. The row is 2 and the column is 2. That is the last part of the diagonal in this one. If we had another row here, the next number in the diagonal would be 3, 3. Okay, so you can see where with the primary diagonal, that's not so difficult. The row number and column number coordinates for each element in the primary diagonal are the same, 0, 0, 1, 1, 2, 2. If we had another row, 3, 3, and so on. Now I will show you the long, painful way to walk the primary diagonal using two loops. I'm going to go through my rows, so I'm going to start at row 0. Then I'm going to go through my columns, but I'm only going to print out the numbers where the row and the column are equal. So when I first come in here, the row is 0, the column is 0. Those two numbers are equal, so I will print out the value at 0, 0, which is the 1. Now this is not really the most efficient way because now the inner loop is going to go from 0 to 1. So col becomes a 1, row is still 0, not equal, skips to the next value for col, which is 2. So now col is 2, row is still 0, not equal. Now it goes back, it advances the row value to 1, comes back in here, and again this isn't efficient. Column is 0. Well, row is 1, column is 0, they're not equal. It loops again on this inner loop. Col goes to 1. Row is 1, col is 1. Yes, now it will print out the 5. But it's still going to check. It's going to take col to 3. The row value is a 1. The value in col is a 3. Those are not equal. Now it goes back here, advances, oops, that should be row, advances the row counter value to 2. Comes in here, column is 0. 2 is not equal to 0. It comes back, it makes col 1. 2 is not equal to 1. It comes back, col becomes a 2. Now row has a 2, col has a 2. Now it's going to print out the 9. That's kind of the long, painful way to do it. A simpler way to do it, since we know that the row and the column values are equal, is to use just one for loop. And I think I'm going to change this to the letter I. So we're not really necessarily thinking of the loop counter as a row and column anymore, since we're only going to have one loop counter even though we still have a two-dimensional array. So I'm going to change it. So I'm going to start at 0. I'm going to loop from 0 to 1 to 2. Remember, in this case, tick.length has a 3 in it because in this two-dimensional array there are 3 rows. So I'm going to loop from 0 to 1 to 2. And I'm going to print out when this is a 0. I'm going to substitute a 0 here and a 0 here, basically printing my 1. This goes to a 1. Now I substitute a 1 here and a 1 here. I print out the 5. Now I becomes a 2. I substitute a 2 here and a 2 here, and I get 9. So this is the better, simpler, easier way to do it. I'm just showing you here, if you're kind of stuck on the idea of using 2 loops every time you're dealing with a two-dimensional array, that would be how you would have to walk the diagonals. But as long as you are understanding that the array is still two-dimensional, I'm still specifying row and column values, but since each time the row value and the column value are equal on the primary diagonal, I can take this little shortcut and do that. Now the secondary diagonal is a little trickier. So look, the secondary diagonal starts at row 0, but that 3 is in column 2. Remember, we start counting with 0. So 0, 1, 2, that is column 2 right there. Now the middle value is still 5 with row 1, column 1, and then the 9 is in row 2, column 0. Okay? So we have a little formula, and I suggest you just memorize it for determining the column value to print out when we're doing the secondary diagonal. We're still going to go from row 0 to row 1 to row 2. We're still going to go in that order. So our row is easy. We can just do one single for loop with a little counter that goes from 0 to 1 to 2. That's fine. So that's the easy part. The harder part is the formula for the column value. But if you use this every time, it should work like a charm. You take the array name dot length, so my array is named tick, so tick dot length, which is 3. You subtract 1, then you subtract whatever value is in your loop counter. So the first time through, I is 0. The length is 3 minus 1 is 2. Minus 0, that's still 2. That's perfect. That gives me a 2 for the column, and the row, of course, is 0. I come back in, I becomes a 1, so my row is a 1. But now my column is 3 minus 1 minus 1 because I has a 1 in it. So 3 minus 1 is 2, minus 1 is 1. That gives me my value of 5. Now I has a 2 in it, so my row will be 2. So 3 minus 1 is 2 minus 2, which is what is in I is 0. So that will give me the correct value for the column coordinate, and that will print out my 9. So you may need to watch this a couple times to think about it. The easiest one to do is the primary. The more complicated one is the secondary, and again, if you can just memorize the formula. The length of the array, always minus 1, then minus whatever value is in your loop counter, your loop variable. Hopefully this isn't too confusing, and it will allow you to think about all the different ways you can walk an array. You can do the diagonals, the rows, or the columns. So think about that. Watch the recordings a couple times if you're not clear. Take the sample code that I've given you in the news items, put it into your compiler, watch it work, change the sizes of the array, watch it still work. Now you could get rid of the hard coding that I've done for the 3. Even though it's a 2D array, remember, like I talked about in one of the recordings, you can use dot length on a 2D array to get the number of rows. And I'm going row by row on that primary diagonal. It's the columns that are changing in different The columns need to be calculated, those numbers, but I'm going in order on the rows, row 0, row 1, row 2 from the top to the bottom. Here, if you wanted to get rid of this, you could do the same thing. Same thing here. So that way, if you take the array, tick, and you increase the size of it just to experiment with it, you won't have any issues. So let me know if you have any questions on this, but it's very important for purposes of the exam that you understand you can walk by row, by column, or by diagonal.